Well, this is Mr. Oman. We're going to be working through the robotics class TestBed exercises. We're going to do the first 22 problems shown in the TestBed document, okay, which I've downloaded from Canvas. Right now I'm just kind of showing you, all right, these are the problems. There's a few hints on that page, a few links. If you download step 2 here, if you download this file called TestBed Oman, download that to your computer, save it. You can then drag and drop that into RobotC. And notice all the green text here has the same problems. Like I'm pointing at problem number 1, the text should be the same. I've brought all of those problems over for you so you can see exactly what the problem is. I'm asking you to type your code in between each green statement, each problem. Okay, I'm going to the robot menu, sliding over. I'm just making sure I've got my VEX 2.0 Cortex selected. Robot menu again, platform, natural language, PLTW. Those have to be in place in order for this to work. I'm going to open up the natural language menu on the left. There's a few folders that matter. Movement, I'll use some commands out of there. The wait folder should get opened up. Until should be opened. And special. The other ones can stay closed. Okay, we're going to be dragging and dropping. So in problem number 1, when the program starts, the right motor should turn on at 1/4 power, 32 for 3 seconds. So I drag start motor, wait, and stop motor commands from the left. Okay, if I am going too fast here, you probably want to pause the video and keep up. So I put the port name right motor right there. It should match exactly how that's typed up there. I'm going to copy and paste just to show you. That's the easy way. So I paste it. I'm going to paste right motor again so it knows exactly which motor we're talking about, which port. And wait time, that's the 3 seconds. The number 32 represents the speed. So 1/4 power out of 127 is the max speed. So you divide that by 1/4 or divide that by 4. 32 is pretty close. Okay, in problem 2, now it's the left motor going counterclockwise. Counterclockwise means we're going to have a negative speed to make the motor go the other direction. I'm just editing the words left motor. Wait is the 2 seconds. Okay, I'm on to problem number 3. You can tell we're going pretty fast, so again, pause if you need to. You can pause and download to your robot and see if it works. So this time we're turning on an LED light, so I went to the special folder and I got turn LED on and off. Now I'm putting the word green into the digital port names, and wait time will be the number 4. Alright, so that's how you turn a light on and off. Problem number 4, the LED should turn on for 2 seconds, then off for a second, and so on. Okay, you can watch and follow what I'm doing here. I basically copied and pasted from problem 3 and brought it down. I'm just editing some of the numbers that are specific to this problem. Okay, right there, that's how long the light should be off, for 1 second. So it's on for 2 seconds, off for 1, then on, back on for 3. So you can tell things how long to be off for, in addition to how long to be on for. Okay, and problem number 5, I'm dragging 2 start motors because we have a left and a right turning on at the same time. So putting those back to back with 1 wait time. The 1 wait time will apply to both motors. Now if I'm telling both motors to turn on, I need to tell them both to turn off. That's why I grabbed 2 stop motors. So again, these are all drag and drop from the left side of your screen. And then you just edit the black text so it works for the problem you're doing. Okay, I just copied and pasted and left motor down. changing it to say right motor, so both left and right are turning on right at the beginning of this problem. The wait time is 3.5. And I copied and pasted those names down. So it seems like I'm going pretty fast here. It's because I'm copying and pasting. I'm doing as little typing as I possibly can. Problem 6, we're going to get both motors turning on at quarter power. So I'm going to go, since that problem number 5 is very similar, I'm going to copy and paste that down here to save me some time. And I'll just edit things as needed. So my wait time is 1.5. I'm going to paste that down below, the wait time, because that's how long I want it to be off for. Okay, copied and pasted it again. This time I'm only going to have the right motor turn on. So I deleted the left motor line. Change the speed to match what it says. Change the wait time to 2.5. And I'll delete that stop motor since we never turned that motor on to begin with. So there's your 2 parts. Leaving a blank line in between doesn't hurt anything. Your robot will read all of this code incredibly fast, so a blank line doesn't change anything. Like line number 62 there. Okay, on to number 7. I'm going to go grab a start motor from above and paste it down. Okay, on this one where the motor starts and it waits around until we press the bump switch. So this is not a wait command, this is an until bump. So this replaces the need for a wait. So start motor, until bump, stop motor for 7. Number 8, I'm going to copy and paste number 7's code down. I'm just going to edit a few things to make it correct. Okay, we have the left motor running at a speed of 25. In the problem it says power. You can think power and speed are the same thing on this project. In number 9, we'll have a until touch command and a start motor. It's a matter of getting things in the correct order so it matches up with what the problem is asking for. Okay, so we're using a limit switch. I'm going to go grab the name, so that's a copy. I'm going to right click and paste it right in there. So it's start motor, until touch, stop motor. Okay, Okay, I have a little bit more to go here. Okay, so I just added another start, wait, stop to finish the problem off. And all I did is I went up above and I found some text very similar to the code that I needed for this one. I just copied it and brought it down to save myself some time. Okay, problem number 11, we're going to get into what's called as while loops. We can start by deleting the asterisks and forward slashes above and below this one. Okay, we want to open that up so it's not pseudocode anymore. You do have to finish off the remaining text so that it works for the problem. Make sure you have a semicolon at the end of each line, like I show here. That allows the program to kick down to the next line and continue reading and separating out one line of code from another. Okay, and the reason I know what to type here is because I'm looking over on the left side of your screen where the command start motor and stop motor are found in the natural language menu. It shows you what they need. Okay, and the rest is just editing so that it matches. Okay, number 12, we're going to get a LED light to blink on and off. Okay, and it says we should do this forever, so anytime you see a problem that says it should do this forever, that means you need a while loop that allows the code to repeat inside of the curly brackets over and over. So I got my while statement, I brought that down from up above, which reads while 1 is equal to 1. Then our light should turn on and off according to the code we're about to place inside the curly brackets. Okay, so we have a turn LED on, wait, turn LED off, wait again. So you will need to tell it how long to be off for in a while loop. If you skip the last wait time, it'll probably just turn on but never off. On to number 13. Okay, we're going to have some motors turning on, some lights, a variety of things are happening here. And this will all happen inside of a while loop. So I'm copying all of number 12 down, then I'm going to delete out the old code. The code that I don't need, and I'm going to paste in some lines that I see above here. So I'm going to paste in a start motor. Okay, so I copied the start motor command down again, down a few lines. So both the motor and the light react at the correct time. Okay, so in the first part, the motor starts going in a positive direction and the light turns on. After 1 second, the motor switches directions and the light turns off. For number 13. On to 14, now we're using the potentiometer, which is the sensor that measures rotation, how much something is turned. So we're going to have a motor start, until we turn the potentiometer rotation to a position that's higher than 2000. So I'm going to go grab the name potentiometer, the port name that I've already given. So our until potentiometer greater than command will take the place of a wait or any other time-based command. Okay, so I'm showing you a variety of ways to make things happen using your robot. So in this case, problem number 15, till potentiometer turns less than a given value, then the light should turn on, and if that potentiometer turns greater than that number, the light goes off. So we're basically making the potentiometer into an on-off switch based on where it turns to. So position is a number, and we're going to use 1500 for both of them, and the port of course is called potentiometer. I just typed PO, clicked on it, and I'm hitting the enter key on my keyboard to get it to accept that name, and enter. And number 15 is all done. Oh, I guess we got to do the while loop. So I type while, left parenthesis 1 equals 1, right parenthesis. That's a left curly brace right after the while, and down at the bottom of the code is a right curly brace. So I'm pressing shift and the curly brace buttons, which are found just above the enter key on your keyboard. Okay, on to number 16. Now we're going to use a limit switch, and until touch is the name there. We will need a while loop, so I'm just getting that set up so I can type code between the curly braces. Until touch, I'm going to drag that in. Until touch, start motor. So until touch is when we press the limit switch in, the motor turns on, and then when we release the limit switch, then something else should happen. So until touch and until release separate the pressing and releasing part of pushing a limit switch in and out. It is a digital switch, so pressing it in gives it a value of 1. When you release it, it's a value of 0. Here I'm just editing things to get it to match what the problem wants. So problem 16 is done. Moving on to 17. We need a left motor to turn on at a speed of 42 for 3 seconds. When the light value is dropped below 1500. So until light is the name of this command, found in your until folder. 1500 comma, and then I'm selecting line follower from the port names. Okay, so that's going to wait around until the light drops below 1500. Okay, there's the end of number 17. Okay, I'm going to copy down the until light command for number 18 and change it to 2500. So basically if a piece of paper goes in front of the line follower, it'll lose some line value. So until light, 2500 should be good. Usually the line follower is reading about 3000 or so as a light value in our classroom. So 2500 will make it pretty sensitive and pretty easy to set off. And when it comes back above, in other words, when you pull the piece of paper away from the line follower, until dark is when the value goes back up above a number, a threshold. Then we want the LED to turn off. Number 19, I'm going to go back to the original TestBed document. I'm actually going to copy and paste the entire hint over here. So things to know here, this is a while loop that repeats. Notice the if sensor value statements. If you just copy and paste those in, like I'm about to do here. Okay, so if the limit switch is pressed in, the first line up there says if the limit switch is pressed in for a value of 1, then the motor should start. Okay, or if the limit switch is 0, meaning it's not pressed in, it stops motor. Same with bump switch, if it's pressed in, something happens, or if it's not pressed in, something else happens. So you can program your robot to do this or that if you use if statements. Okay, so you can have number 19 just by copying and pasting. Number 20, we're going to use that same text. Now we have to do some editing in order to make it apply to the problem that you're working on. So I'm just doing some editing here is all that's happening according to the problem. So if my bump switch is pressed in, then my left motor should turn on. I use speed of 63 here. It doesn't really matter that much what the speed is. Or if it's not pressed in, then it's stop motor, so the motor's not running. Stop motor, left motor. Okay, and then up in the limit switch area, our right motor should turn on with the limit switch. Okay, and that one is all done. On to number 21. So for 21 here, I've copied and pasted. I'm just editing the appropriate commands inside of each set of curly braces. So in this case, for the limit switch, I need the right motor to turn on for 1 second. and then it should turn around for a half a second with the negative speed. So we're just applying the knowledge from number 20 here into 21 and making it match the problem. Okay, now we're into number 22. Okay, we're going to do an if-else statement. So would you please go back to your document and click on the hyperlink for a clue. It'll bring you to this document, which shows you what it looks like to type an if-else statement. So in other words, if this condition happens, some commands will run, or else something else will happen. So slightly different than the sensor value statements we just did. So I'm just going to grab number 21 and copy it down, and then I'll correct it. So I deleted all of the bump switch information and I replaced it with the word else, and a left curly brace and a right curly brace. My code will go between those two curly braces. And I grab the text from above. Okay, once you get it all corrected, you are done with the first 22. Problems 23 and 24 will be extra credit for you. And if you are welcome to look those up online, do some Google searching, see if you can figure it out without the help of this video. That's it.